Single inheritance. You're writing a program to help organize vehicles at a camp. While all cars are vehicles, not all vehicles are cars. For example, some of the vehicles are boats, RVs, golf carts, etc. Considering all of these vehicles have a color and a max occupancy, there would be a lot of redundant code if we put those attributes in every class, like below. What if, instead, we have one vehicle class that has the color and max occupancy attributes, and then the car and boat classes would only include the attributes that are specific to them. So class car would have number of tires, class boat would have number of life jackets. We would just need a way for the car and boat classes to access the attributes from the vehicle class. Luckily, this is where object-oriented programming truly shines: inheritance. Inheritance is where a child class inherits the attributes and behaviors of a parent class. In our current example, the vehicle class is the parent class, and the car and boat classes are the children classes. This is an example of single inheritance, when a child class inherits from just one parent class. Parent classes are also known as superclasses, while child classes are also known as subclasses. In Python and other object-oriented programming languages, everything is an object. While we have been writing our own classes and creating our own objects with unique attributes and behaviors, everything originally inherits from the object class. To the right is a more accurate representation of how inheritance works. Child inherits from parent, parent inherits from object. Earlier in the course, when we used len, that was a method from the object class that finds the length of an object. That object can be a string, a list, or another data structure, all of which are objects. Inheritance allows us to use data and behaviors from certain classes in other classes, instead of rewriting code over and over. Inheritance in object-oriented languages takes a parent class, adds new methods and data, and cannot subtract. You use inheritance when the new class is of the old class, and this will make sense in a little bit. The relationship does not change over time. Above all, try to create relationships with inheritance that make sense. The is-a relationship is a useful way to test out whether it makes sense to make a class inherit from another. For example, a car is a vehicle. A motorcycle is a vehicle. A convertible is a car. So this would all make sense to set up the inheritance this way. However, not all vehicles are cars, so vehicle shouldn't inherit from car. And not all vehicles are motorcycles. So convertible is a car, is a vehicle. This is the direction of inheritance. For simplicity's sake, let's focus on just the vehicle and car classes. Here is the syntax for setting up an inheritance in Python. So the parent class is vehicle, class vehicle. And note, we can put pass inside of our classes or functions that we haven't written yet so that we can run the code. Here is the class that is inheriting, the child class, and we put the parent class here inside parentheses. Let's add an init method to the vehicle class. We will want to access these attributes inside of the car class. For now, our object X will just be a vehicle object to show that the parent class works. So class vehicle, we have our init method. When we create our object, we can set the color and the max occupancy. So blue, 5, and we can print those attributes like that. Now let's add an init method to the car class. We will now make X a car object. We can send it the argument 4 for the number of tires. How can we set its color and max occupancy? So here we have tires, which is an attribute that is specific to cars, but we want to access color and max occupancy. We can set attributes from the parent class by setting them directly in the init method in the car class. However, Next, we will do this in an even better way. So here we can access the color attribute with dot notation with the vehicle class name, but there is a better way. The super keyword is a way for a child class to access a parent class. We can include the code below to send the color and max arguments up to the parameters in the vehicle init method. So super with parentheses, dot, and then we're going to call the init method from up here. So this super is going to call to the vehicle class since car inherits from vehicle. And it's going to take these parameters, send them as arguments up there. And then this X object is going to have 3 attributes: tires, color, and max. There's a lot going on here, so let's trace the path that just one argument takes. So when we create our car object X, let's trace what happens to this word blue, this string here. At first, it is sent as an argument to the color parameter in the car init method here. Then it is passed as an argument to the init method in the superclass, which is vehicle. So it goes from here up to this parameter, and where it is then saved in self.color as this attribute. So this string travels through the code this way. Then when we print x.color, it's reading this attribute up here and then printing it right down there.